Electron orbitals. An electron shell is the collective states of all electrons in an atom having the same principal quantum number, visualized as an orbit in which the electrons move. An orbital is a specification of the energy and probability density of an electron at any point in an atom or molecule. The closest orbital to the nucleus, called the 1s orbital, can hold up to 2 electrons. This orbital is equivalent to the innermost electron shell of the Bohr model of the atom. It is called the 1s orbital because it is spherical around the nucleus. The 1s orbital is always filled before any other orbital. Hydrogen has 1 electron, therefore it has only 1 spot within the 1s orbital occupied. This is designated as 1s to the power of 1, where the subscripted 1 refers to the 1 electron within the 1s orbital. Helium has 2 electrons, therefore it can completely fill the 1s orbital with its 2 electrons. This is designated as 1s to the second power, referring to the 2 electrons of helium in the 1s orbital. On the periodic table, hydrogen and helium are the only 2 elements in the first row. This is because they are the sole elements to have electrons only in their first shell, the 1s orbital. The second electron shell may contain 8 electrons. This shell contains another spherical s orbital and 3 dumbbell-shaped p orbitals, each of which can hold 2 electrons. After the 1s orbital is filled, the second electron shell is filled, first filling its 2s orbital and then its 3 p orbitals. When filling the p orbitals, each takes a single electron. Once each p orbital has an electron, a second may be added. Lithium contains 3 electrons that occupy the first and second shells. 2 electrons fill the 1s orbital, and the third electron then fills the 2s orbital. Its electron configuration is 1s2, 2s1. Neon, on the other hand, has a total of 10 electrons. 2 are in its innermost 1s orbital, and 8 fill its second shell. Therefore, it is an inert gas and energetically stable. It rarely forms a chemical bond with other atoms. Larger elements have additional orbitals, making up the third electron shell. Subshells D and F have more complex shapes and contain 5 and 7 orbitals. Principal shell 3N has S, P, and D subshells and can hold 18 electrons. Principal shell 4N has S, P, D, and F orbitals and can hold 32 electrons. Moving away from the nucleus, the number of electrons and orbitals found in the energy levels increases. Progressing from one atom to the next in the periodic table, the electron structure can be worked out by fitting an extra electron into the next available orbital. While the concepts of electron shells and orbitals are closely related, orbitals provide a more accurate depiction of the electron configuration of an atom because the orbital model specifies the different shapes and special orientations of all the places that electrons may occupy.